Hey everybody, this is the guided practice worksheet for week 7.1. This is section 9.1 in your book, and it's the introduction to functions. Now, in this section, we're talking about the difference between a relation and a function, and that's hopefully going to be illustrated in this example. Now, this should be a pretty short video, so hopefully this isn't going to take up too much of your time. For section 9.1, introduction to functions, we're talking about relations, and it says graph the relation x equals the absolute value of y, and use the graph to determine the domain and the range. Okay. Well, what we can do is we can either plug in a bunch of values of x or a bunch of values of y. Let's see. Let's use a bunch of y values here maybe. -2, -1, 0, 1, 2, and 3. The absolute value in each one of those cases is going to be 2, 1, 0, 1, 2, and 3. And so as we begin to plot those points, we can see that each one of these is an ordered pair. This is the ordered pair 0, 0. So this will pass through the origin. This is the ordered pair 1, -1. So that's over 1, down 1. 2, -2. Over 2, down 2. And then over 1, up 1, over 2, up 2, and over 2, up 3, and those, over 3, up 3, and those seem to be the only points that we've decided to plot here. Now we could have plotted anything, but that's the idea. And if we begin to connect these dots here, as this relationship will continue on in both directions, we got a graph emerging here. So this looks like the graph of x equals the absolute value of y. And it's a collection of a bunch of ordered pairs. Now, these aren't the only ordered pairs. There are more ordered pairs involved here. Dot, 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 like in general, x and plus or minus x is in the list there. Whatever x is, you will get 2 points for each x value. And that leads us to answer this question down here before we talk about anything else. Is this relationship a function? And as far as looking at this as a collection of just ordered pairs, the answer to that question is no, because here is the input 2. And here is the input 2. So same input, but it is associated with different outputs. And those aren't the only two ordered pairs that have that issue. Just about every ordered pair has a twin here. So here, the input 2 has multiple outputs, in this case 2 and -2, or each x value except for 0 has 2 outputs. So this is not a function. Now, in terms of this question down here, what's the domain and what's the range? Well, the domain is the collection of all x values. And so if we look at our graph and we kind of, what's the best way to describe this? Smash this graph flat. If we take our hands and put it on both sides here and slap them shut, this is going to collapse. This graph will collapse onto the x-axis, and we'll be left with a single point here and then an arrow pointing to the right. That is to say, the graph goes as far left as x equals 0, including x equals 0, and the graph continues to the right, well, to infinity. So this is the point 0, 0. And as far as we're concerned, the domain is from 0, including 0, up to positive infinity, or the x values are greater than or equal to 0. Now, when it comes to the range, instead of smashing it flat on the x-axis, we're going to take this graph and we're going to smash it flat onto the y-axis, and we're going to get something that looks a little bit like this. Let's see, I'll draw it off to the side a little bit. Now, to explain this in another way, when we talk about the range, we're just talking about all the different y values. So how far down does this graph go? Well, as indicated by these arrows that I've drawn here, this graph will continue down forever as far as the y values, as well as up to positive infinity. That is to say, it will obtain every value. And so we might say that the range here is negative infinity to infinity, or we might use the symbol for all real numbers. So this was the domain, and this was the range, x versus y's. And then it says, how could we have determined that this was not a function using only the graph? Well, the idea there is what's called the vertical line test. So if I draw any vertical line, and that vertical line intersects the graph in more than one location, as it seems to be doing here. Well, what's going on here is this is directly checking for the definition of a function. So if we talk about the VLT, the vertical line test, each vertical line that you draw, if you guys recall, is the equation x equals a constant, or in this case, x equals 2. And we can see here that when we draw the vertical line x equals 2, it corresponds to more than one y value, negative 2 and positive 2. So visually, each vertical line is an x, the value input, and if the line, the vertical line, intersects the graph at multiple locations, then that x value input has multiple y values or outputs. So how could we have determined this using only the graph? Use the vertical line test. And that's actually reiterated down here below. So the vertical line test, how does it work? If any vertical line intersects the graph at 2 or more points, the relationship is not a function. And that's the idea. So what are the key features here, and what do you need to take away from this exercise? Key number 1, you need to know how to plot points to graph a relation. Key feature number 2, domain and range graphically. Key number 3, the difference between a relation and a function. Key for the vertical line test, and know how to use that. So those are the keys that you want to come away with here. Okay? Practice, practice, practice.